the station problems we did in class today. The first station was given the parent function x squared. We wanted to translate it 4 units right and 1 unit down. So our new equation, putting it in vertex forms. Remember, the x-coordinate of the vertex is inside the parentheses with the x, and it's the opposite of what you think. So it's shifting right, it's really a -4. The square is on the outside. Outside the parentheses, it's normal. So we actually shifted down 1. So there's our new equation. For my students, what I did when I taught this was I did a t-table of values for the original parent function. So again, thinking parent function, x squared. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So when you graph it, all you do is shift the vertex and then plot the ordered pairs from the parent function. Okay, so our first ordered pair is the vertex. And as we said, we shifted 4 units right, 1 unit down. So we plot the ordered pair 4, -1. And then again, going back to the parent function, this means from the vertex left 2, up 4. So that lands us here. This means from the vertex left 1, up 1. 0, 0 means from the vertex you don't go anywhere. Right 1, up 1. And the last one is right 2, up 4. Make sure your parabola is rounded like a U, not pointed like a V, and that you have arrows at the end to show that it continues forever. Station 2, the first question was to use the quadratic formula to give an exact answer. So x equals, actually let me identify, A is 3, B is -1, and C is -9. So x equals -b, or the opposite of b, plus or minus square root, b squared. Again, I drop the negative when I square it, minus 4 times a times c, all over 2a. Simplifying under the radical, 4 times 3 is 12, times 9 is 108, all over 6. Adding inside the radical, we get the square root of 109, which does not have any factors, so any perfect square factors, so we can't simplify that, so that is our exact answer. Part B, solve by factoring. This is the AC method, where we multiply 2 by 1. So our T-chart is what multiplies to 2, and we're still looking at the B to see what it adds to. We're adding to -3. So what numbers multiply to +2 and add to -3? I kind of run through the list in my head, and I came up with -1 times -2 is +2, and -1 plus -2 is -3. So what we do with those two numbers is we have to split up our -3x as -1x minus 2x in order to factor, and then we factor by grouping. So we're looking at this group separately from this group. So from my first group, the common factor is an x, leaving us with 2x minus 1. From my second group, what I notice is that the signs inside this parenthesis are the opposite from the ones I have sitting there. So I want to factor out a -1 so that I have a 2x minus 1. And then I can factor out that 2x minus 1 that's common to both terms, leaving me with x minus 1 in my second binomial. So there's the factoring by AC method. Next is we have to solve. This is the zero product property, and what that says is that the only way to multiply to 0 notice we're multiplying to 0 because we've got a binomial times a binomial, is to multiply by 0. So that means either my first binomial is 0, so I set up one equation, or my second binomial is 0, so I set up my second equation. Solving the first one, add 1 to both sides and divide by 2. And the second one, you just add 1 to both sides. So the two solutions to the original equation are x equals 1/2 and x equals 1. Third question on this station was identify the discriminant. Remember, the discriminant is what's under the radical in the quadratic formula. So that's the b squared minus 4ac. That's the discriminant. A is 1, b is 2, c is 5. So substituting into b squared minus 4ac, I get 2 squared minus 4 times 1 times 5. 2 squared is 4. 4 times 5 is 20. So my discriminant is negative. What that means is if this were under a radical, I would get imaginary answers. So I would get 2 complex solutions. If my discriminant was positive, I would get 2 real solutions. And if my discriminant was 0, I would get 1 real solution. Station 3, graphing. So this was from a while ago, so we had a lot of stuff to remember in order to graph this. First of all, think about when you're on a graph, wherever you cross the x-axis, that's an x-intercept. The value for y on the x-axis is 0. So if we substitute 0 for y and solve for x, we'll get our x-intercepts. So this one, the first way that I look for to solve a quadratic equation is factoring. So is there anything, this is the t-chart, that multiplies to -5 and adds to -4? Well, the only numbers that multiply to 5 are 1 and 5. So I just have to figure out if any of the sign combinations will work to give me a -4. So I'm thinking -5 times +1, and that works for -5 plus 1 as well. Because the x squared term has a coefficient of 1, this is one of those that you can just factor right away. X minus 5, x plus 1. Same thing, zero product property. So in order to solve this, I set each binomial equal to 0. So x equals 5 or x equals -1. So those are our 2 x-intercepts. All right, so going back to our little graph here, if we think about the fact that on the y-axis is where our y-intercept occurs, and everywhere along the y-axis, our x value is 0. So to get the y-intercepts, we substitute 0 for x. Well, my first 2 terms go to 0, so my y-intercept is -5. The vertex, if you look at it, there's 2 ways to think about this one. Our original equation is in standard form. So if you're looking at it in standard form, to find the x-coordinate of the vertex, you use the formula x equals the opposite of b over 2a. However, because we already have our x-intercepts and we put it in factored form, you can also find the vertex by averaging your x-intercepts. So I'm going to do it that way. My x-intercepts are 5 and -1. So the x-coordinate for my vertex is 5 plus -1 over 2. 5 minus 1 is 4. 4 divided by 2 is 2. To find the y-coordinate of my vertex, I have to go back to my original equation. X squared minus 4x minus 5. And substitute 2 for x. So we get 2 squared minus 4 times 2 minus 5. 2 squared is 4, 4 times 2 is 8. And 4 minus 13 is negative 9. So the vertex is, my x-coordinate is 2, and my y-coordinate is negative 9. The other two pieces were identify open up or down and max or min. Remember, to identify it opens up or down, you look at your a. If the coefficient of your x squared term is positive, it opens up. And if it opens up, the parabola will have a minimum value. So we're going to use all of this information and put it together on the graph. I think I'll use my space right here. So I know that my vertex was at negative 9 on the y-axis, so I'm going to make my x-axis fairly high so I can get down to negative 9. All right, so plotting my ordered pairs, my x-intercepts, I have 5, 0, and negative 1, 0. My y-intercept was negative 5. And my vertex was 2, negative 9. Off to the left, I have 2 ordered pairs, so that gives me a pretty accurate way to draw my parabola. Off to the right, I only have 1. So in order to get a second ordered pair off to the right, I can use the fact that there's an axis of symmetry through the vertex. And I'm going to reflect my y-intercept over the axis of symmetry. So it's 2 away from the axis of symmetry. So I'm going to go over 2 and plot the point. Again, make sure your parabola is rounded and you have arrows. Station 4, convert to vertex form by completing the square. So either way, whether you had Ms. Pedersen or whether you had me last trimester, you cut the middle term in half. The thing that's different is just the way that I format it. So I cut it in half by factoring out a 2. And then whatever value is left after I factor out the 2, I add that squared. Now when you're solving by completing the square, you would add 4 squared to the other side of the equal sign. But when you're putting it in vertex form, you're working entirely on one side of the equal sign. So to balance that plus 4 squared, I have to subtract 4 squared. And then I can't lose, I had a plus 7 in my original equation, so I can't lose that either. So this puts it in the perfect square trinomial form, so I can factor this to x minus 4 squared. The subtraction sign comes from right here, and then the 4 comes from here. Outside my parentheses, I have the negative 16 plus 7, which is negative 9. So it's now in vertex form. Second question at this station was simplifying with complex numbers. So we use distributive property. 3 times negative 6 is negative 18. 3 times 2i is 6i. Negative 4i times negative 6 is positive 24i. And negative 4i times 2i is negative 8i squared. So I know that this term is going to turn into a real number because I squared is negative 1. So I have negative 8 times negative 1 is positive 8. Negative 18 plus 8 is negative 10. And combining my two complex terms, my imaginary terms, I have 30i. Station 5, this was one with the basketball follows the path, and the shot is made into a 15-foot basket. So remember, h of t represents the height. When the basketball lands in the basket, it's 15 feet off the ground. So we substitute 15 for h, and the question is how long? T represents time in seconds. So what I notice is when I'm solving a quadratic equation, I look at the coefficient of t squared to determine which method I want to use. There's 4 ways to solve a quadratic equation. The first one I usually look for is factoring. Then I would look for solve by undoing. There's also completing the square. And finally, quadratic formula. So noticing that my t squared has a coefficient of -16, I automatically rule out the first three, and I jump to the quadratic formula. In order to use quadratic formula, you have to have your equation equal to 0. So I'm going to subtract that 15 from both sides. And then quadratic formula, we saw earlier, t equals the opposite of b, plus or minus square root b squared minus 4 times a times c, all over 2a. And because this question is how long does it take, we're not going to get an exact answer on this one. We're going to go ahead and get a decimal. Some of you guys like to simplify before you substitute into your, or plug the numbers into your calculator. I type all of this into my calculator at once. I just use a bunch of parentheses. So my first set of parentheses, I need around the entire numerator. Then I need another set of parentheses under the square root. Right here, if this is a little less complicated to think about, I would type those as times signs instead of using parentheses because they get a bit complicated. And then same thing down here, instead of parentheses, I'd use that as times. And you need another set of parentheses in your denominator. So we get, I didn't work this one out ahead of time. One. So this one didn't factor. We only need the positive answer. So what I knew was in my denominator, I was going to have a negative value. So I did -25 minus. You can't type a plus or minus sign into your calculator. You would have to do this twice. So I knew I wanted my numerator to be negative in order to have the negative divided by negative give me a positive answer. If I did -25 plus, it would have given me a negative option, which doesn't make sense for this situation. So it took them 1 second to make the basket. And our last questions, simplifying an absolute value. Remember, on a coordinate plane, absolute value is distance from 0. So we use distance formula. Because we're looking at the origin and 0, the distance formula simplifies really nicely. So the absolute value equals the square root of 9 squared. And you can, again, drop the negative because -9 squared is the same as +9 squared. Plus, and then what you do for the second piece is you just take the coefficient of your I term. Because once you square the I, it becomes -1. So it's 1 squared. So that coefficient, again, is the coefficient of your I term. 9 squared is 81. 81 plus 1 is 82. And there are no perfect square factors of 82. So that's as simplified as it gets. And our last question, when we're dividing complex numbers, we multiply by the conjugate. So that, remember, is where you change the sign on the imaginary part of your number. In the numerator, multiplying each piece by 6, I get 24 plus 6i. In the denominator, remember the shortcut is you multiply your 4 times 4 to get 16. And negative I times positive I gives you -I squared. So what happens in the denominator, that I squared becomes -1. -1 times -1 is +1. So we have 24 plus 6i in the numerator over 16 plus 1, or 17 in the denominator. And then in order to put it in standard form, we use that butterfly method and get 24/17 plus 6/17 I. Alright, so that was the review we did. Again, quiz tomorrow, so make sure you study up on whatever concepts that we just went over in the station problems that you still struggle with. I am available tomorrow before school, starting at 7:30, and everything that is on the quiz was on one of the station problems, so there won't be any surprises.